Hi ladies, sorry I can't be with you today. Hope you're enjoying your free period, some time off, and some new class structure. Today we're going to get started by looking in our Chapter 11 notes on the first page. So I'd like you to scroll down to where it says regular polygon, that's right here. Okay, we're going to draw a picture of regular polygon. Remember, regular polygons, they can have any number of sides. Let's see, let's make this an octagon. Those are generally pretty easy to make, and I apologize, these are horrible drawings here. And remember, all the sides are going to be congruent for this regular polygon. So you want to mark all of those sides congruent. And all of the angles are congruent as well. Okay, so all sides and all angles are congruent. Now the formula for this is the area equals 1/2 the length of the apothem times the perimeter. So that's 1/2 AP. Okay, we'll explain what those mean in a minute, but for now, just get this down. Okay, so A stands for the apothem. I know that's hard to say. And P stands for the perimeter. Okay, remember to find the perimeter, you add up all the sides. So if you go to your 11-6 notes in your note packet, they look like this. And remember, you can always pause or fast forward or rewind this video if you need to. If you go to this page, it's got all the vocabulary that you will need to know to find the area of these regular polygons, okay? So here's a picture. In this case, we've got a hexagon because it has 6 sides. And this would be the center of the hexagon, because if you had a circle around here, that circle would also have the same center. And that's what they mean with all these mumbo jumbo over here. Okay, so the center of the polygon is right there in the center. Then if a line goes out and goes to a vertex, it's called a radius. If a line from the center goes to at a right angle to a side, it's called the apothem. Okay, so A for apothem. It also looks like an altitude, right? Perpendicular to a point. So you can think of apothem or the altitude. That's how I remember it. And then you're going to have side lengths, and every side is going to be the same because we do have a regular polygon. Okay. The central angle, so C is called the center. Okay, and the central angle is just the angle that is made by 2 radii. Okay, see how it touches 2 vertices here? That's important. Okay, to find the central angle, like say I have something that has 10 sides. Well, in the very center of a polygon, you have a circle, so that's equal to 360 degrees. We'll say I have a polygon then with 1, 2, 3, 4, 5, 6 sides. I'm actually going to be splitting my 360 into 6 parts. So a 6-sided polygon, the central angle is going to equal 360 divided by 6, which is 60 degrees. Okay, if you have a 5-sided polygon, you would do 360 divided by 5. If you have a 7-sided polygon, you would do 360 divided by 7, and so on and so forth. Okay, so we're going to start with some examples here. So first one is if we want to find the measure of one interior angle in a polygon. Okay, so like I said, all of the angles in the very center add up to 360. So whatever we want to do, however many sides we have, we're going to divide by 360. Or I'm sorry, take 360 and divide by that number. Okay, so for example, this polygon has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So a central angle is going to equal 360 divided by 10 for 36 degrees. Okay, in the second example, we have 4 sides, 360 divided by 4 is going to give us a central angle of 90 degrees. So that means that if I draw a point in my center, each of these little angles is going to be 90 degrees. Okay, and you know that because the regular polygon that has 4 sides is the square, and you know that the diagonals of a square are perpendicular. Okay, let's move on to another type of example. So remember, we learned that the formula for the area of a regular polygon is 1/2 the apothem times the perimeter. Okay, so when you're finding the area here, you're looking for 2 things. Okay, the length of this little line from the center to a right angle, and it's got to have a right angle here. Okay, and then the perimeter of the whole shape. So in number 5, let's do this one together. So if you need to, feel free to pause this video, give yourself a chance to draw the figure. Okay. So in this case, our apothem is 6.5. Our perimeter, okay, notice each side is 9.4, and we have 1, 2, 3, 4, 5 sides. So we're going to multiply that 9.4 times 5 to get our perimeter. Do some calculating over here on the side. Do the same. 9.4 times 5 is actually 47. So our perimeter is 47. Our apothem is 6.5. And then it's just plugging those into our formula. So A equals 1/2 6.5 times 47. I'm going to plug that in over here. You should do the same. And then I got 152.75 as my area. Okay. Let's look at number 6. So number 6, right here. Again, we're going to use the same formula. So our area is 1/2 the apothem times the perimeter. Now the tricky part about this one is that we don't have side lengths. Okay, notice we're only given our apothem. So we have to find the side lengths. This is a little bit tricky, but it helps if you draw your radii, or 2 radii here. So I'm going to go ahead and do that. Okay, so I know that A equals 7√3/3. Now when you don't have the side lengths, you're going to need to find the central angle here. So the central angle is going to be 360 divided by 3 because we have 3 sides, or 120 degrees. Now notice the central angle would be this whole angle here. But we don't have the whole angle, instead we have half of it. So that means that this angle right here, I'm going to draw an arrow to it, is 60 degrees. So it always helps if you redraw your stuff off to the side. Make it I'm going to even make it bigger than that. Make a real big triangle. Okay, so we know that our apothem is 7√3/3. This was a 60-degree angle. Notice anything special here? We have a 30, 60, 90 triangle. Okay, so in case you forgot your 30, 60, 90 rules, you can look them up. Okay, I'm just going to rewrite them over here. Remember, the short side is the hypotenuse divided by 2, or you can say the hypotenuse is 2 times the short side. And you also know that the long side is the short side times the square root of 3. Okay, so in this case, this is the short side here. We want to find the long side because the long side is going to be half, notice these are the same, it's going to be half of the side of our triangle. So the long, and I'm going to call it L, so L equals 7√3/3 times the square root of 3. Well, if you simplify those, 7 times, or the square root of 3 squared is just 3, so we have 7 times 3/3. The 3's cancel out, and your long side is 7. Well, remember, this was half of this triangle right here. So if half of it is 7, the whole thing is 14. Okay, I'm going to give you a second, because I am going to erase this information so that we have, well, actually I will. I'm just going to scroll down a little bit more. Okay, ignore this for a second. So the perimeter then, because each side is 14 of our triangle, the perimeter is 14 times 3, which is 42. Okay, so we found our apothem, we found our perimeter, then we just need to substitute those into our area formulas and we're finished. So our area is 1/2 7√3/3 times 42. And I know you're going to get frustrated because of these radicals. Don't, they're just numbers. Okay? Take all of your whole numbers at a time. So we have 1/2 times 42. That's 21. And then we have times 7√3/3. Okay? See if you can simplify anything here. 21 divided by 3, that's 7/1. And then I have 7 times 7 times the square root of 3, or 49 times the square root of 3. And that would be in square units because we're finding the area. So I am going to end this video here. If you need more examples, I'm going to, please stay tuned for part 2. So I will do another set of example problems for those of you that need it. If you feel like you can try these on your own, go ahead and start your homework. You can always come back to this video if you need to.